All right, let's get the audio working, make sure everything is good. All right, looks like we got some green bars, not clipping. Let's make sure it's coming through on the stream. That looks good. All right, how's everyone doing today? I thought we'd take a brief break from the microcorruption that we've been going through over the past, I don't know how many sessions, maybe 10, 12, however many it is, to get to work on building a disassembler for the MSP430. We have been using the... Actually, let me pop it up. We've been using the one of the community modules for the MSP430 for a few of the levels here. MSP430, made by Josh Watson. This is somewhat maintained. It looks like the last commit is sometime in 2019. Something that we've noticed is that a lot of the emulated instructions of the platform don't exist on here. So let's see here, MSP430 instruction encoding. I think this is like the magic thing to type, and we can get to some of the docs. Yeah, so like all of these instructions that have a little star right here, these are all virtual or emulated instructions, and basically what it's doing is it's creating an additional instruction that is a subset of another one. So I think, let's see, where is it, like pull or push or pop? Yeah, so pop is a emulated instruction, so popping an item off the stack. I believe it's implemented with the move instruction, like under the hood. It's like an encoded move, and then one of the indexing modes for the source will increment the register +2. Hey, Mr. Edmakes. How you doing? So, and we'll get into all of that crazy stuff in a few minutes. I need to pull up a few more documents. I'm doing well. It's like I already said, taking a quick break from what we've been doing recently, so excited to go work on something else. I also have some of these came in from China on Friday. These are some RISC-V modules using the Buffalo Labs 602. Maybe tomorrow or sometime this week, we'll be prototyping up a development board for these. Pretty much just like one of these, a voltage regulator for it and USB. But basically just like getting like a good like RISC-V target. These are meant to be competitive with the ESP32 or 8266. If any of you have worked with them before, but they're really exciting. They're like 99 cents a piece, which is great. They're much cheaper, and we'll see what we can get. But today is the MSP430. Yesterday I spent a bunch of time trying to get a Rust environment set up. Like I said on stream like a handful of times. I think now I am really not a Windows person, but I can't really run Linux well on here, at least with the stuff that I want, because I have an NVIDIA graphics card, and the Sway window manager with Wayland does not support NVIDIA without using like the Nouveau driver, which is apparently shit. So we're running Windows for the time being using WSL and whatever. So I have everything running. We're gonna be using CLion with Rust. I created this library last night just to get started to make sure everything worked, and it does. We are going to need to open up a few more things. There is this reference here, and there's also, I think this is the one where it is, yeah. So this table will tell us how the actual instructions are encoded. We also can reference the code here. I'm not gonna. I think I said already. The goal of this is to bring this into Binary Ninja, and implement like a native plugin for MSP430, handling all of the missing emulated instructions. So partially using this to learn a little bit more about MSP430, partially using it to learn a bit more about building out modules for Binary Ninja, because I'd like to do some more development, build some file loaders for other embedded platforms, and potentially some more complicated architectures in the future. MSP430 is super simple. As you can see, there's only like a handful of instructions that exist, and there are the virtual ones, but they're all implemented via other ones, so we're not going to have to parse a whole bunch of extra stuff. The one thing I think that is going to be somewhat difficult here is the lifting. We luckily have a lot of that already done here, so we can reference it. I've never looked at the Binary Ninja lifting code or how to work with it. I know very little about the LLIL, which I believe is what we lift to. I don't think you lift it to like the HLIL. So it's going to be an interesting learning experience once we get to that point. But we're not there yet. We got to get parsing and decoding working first. I don't really know much about what the interface is going to look like yet for Binary Ninja. I haven't really looked at the API docs. So I think that the way that we're going to end up approaching this is we're going to build a decoder that can take a reader or read. I forget what the trait is called in Rust, but it's probably going to take a read, and attempt to decode from there. One of the nice things about this architecture is that all of the instructions are, I think they're in multiples of 2, but there might be 3. But we don't have to break anything down into like under bytes or anything like that. So it should be relatively nice. The one problem we may get with this is that Binary Ninja, like from when it passes it off to the module, it may need to know like how much data it needs to pull ahead of time. Oh, did we just lose connection? Uh-oh. Looks like we're still streaming. Okay. Great. It might just be the stream manager from Twitch being problematic. Everything looked good here. I think it's still going. So we're going to implement this right now with our API being taking in a reader probably, so it can read in as many bytes as necessary, because I'm not exactly sure what the parsing is going to look yet. It seems like from the first byte, if not just the first nibble, we should be able to determine the type of instruction. The way that they split up the architecture is there's a handful of different types of instructions. So you have your single operand arithmetic, your conditional jumps, and 2 operand arithmetic instructions. And it seems like so everything here is little endian. We should be able to read the high byte first, as you would little endian. And so I think just reading the first nibble, we can understand like what the instruction is, and then read as much more as we need to once we kind of figure that out. Because there are certain instructions, like I believe maybe not these. Where were they? I think it's the 2 operand arithmetic ones. I think these can take 4 bytes, because some of the values that you put in, and these might as well, but some of the values that you put in like are immediate numbers. So like when I say immediate, it's a term used for addressing. It just means that it's the like the literal value. some of those can be up to 2 bytes wide. 2 bytes wide because they're 16-bit, and so we need to be able to account for that. So I think the approach we're going to take is to basically read in the first byte and then figure out what kind of instruction it is here, and then we'll branch from there and start handling the different types. That seems like it might work the best. We might find that that's terrible and go with something else. I'm going to do a few things first. One of them is I want to get some actual code. Maybe not. Maybe we should just start with getting like a function built. I think we're going to end up probably changing a lot of these names and stuff in the future. I don't really have like a strong idea of what the full API is going to look like yet. But I think that we'll start with this and go from there. So I think what we're going to do is we're going to take in some kind of reader, and then we're going to return either like an option of some kind of instruction. So basically, if we don't decode properly, we'll let it know that we'll return like a none, and it'll just signify that we're the current area that the cursor is at in our input doesn't contain a valid instruction. And then that way we know we can always move it forward by 16 bits probably, if not 8, and try like the next one until we get to one that is valid. So we're probably going to need to have some kind of trait, which is an instruction, and I don't know what that's going to look like yet. But for now, let's just return none. Of course, are we going to want to use a dyn here? We'll just return a string for right now, because it doesn't really matter. And stock. This is what I want, I think. Rust documentation. I need to see what that, yeah, this is what we need. It's going to be standard IO. Yeah. It's been a very long time since I've written Rust. And so I think this is going to be a little bit of a rough start to get going here. But I think we're going to do read. All right. We're probably going to want to figure out what implements read. I think we can use vec. Because your traits read and write are implemented by a number of other types, you can implement them for your own types too. As such, you'll see a few different types of I/O throughout the documentation in this module. Files, streams, and sometimes even vec. For example, read adds a read method. So this seems like the best way to go. And what we're going to end up doing for all of our test data is probably using like a vec of U8. And that'll allow us to write our tests, but also if we wanted to pass in like a real file handle, that real file handle should also implement read. And we may want to change this later down the line, but this seems to be like a pretty straightforward way to handle this. I guess one thing to ask also is, all this legible, should I switch it out for another font, make it bigger? It's readable for me, but I don't know how it looks on the stream, and I haven't really had much time to like really like play around with like changing themes or anything on here. So move these down a little bigger. Sure, we can do that. I think that is in here. The editor. Control mouse wheel. Are you lying to me? Oh, okay. We gotta... There. How's that? So we can get rid of this test. We don't really need it. Empty. So the first test we're going to write is just to make sure that we return nothing when there's no data. So we're going to do data equals vec. And next instruction data and we need to use next instruction, right? Is that what's this called? MSP. Cargo. What is this called? Is it just super? Yeah, all right. Great. Let's run the tests, make sure this works. Not found in the scope. Because we gotta include that as well. Oh, I don't need to do that. I just need to do that. Like I said, it's been a little while since I've written some Rust. Gonna take a little while. The read trait is not implemented for vec. Consider adding a dereference. I don't want to move it. Vec u8. I don't see why this wouldn't. I guess we don't have to care that it's consuming it, but no trait bound for vector read. The compiler doesn't know that it doesn't implement read. The code in question will work, but the vector is coerced to a slice. Cannot apply unary operator. That's the problem, I believe. If this is intentional, prefix it with underscore reader. Okay, cool. That worked. So we know that when we get an empty slice, it fails, or it succeeds properly because we have just returning none here. We probably want to define a trait that is an instruction. I'm kind of curious what the best way to do this is. I guess we could start with doing a like a specific type and maybe move to a thing later. So let's do no, it's not right. It's a struct. All right, so reader from we want to do I don't know what the best way to read like 1 byte in is. Like we get an iterator, so maybe that's the move. So yeah, I mean we can do this kind of janky right now. I'll just do I guess we just do 1. Match reader read what does this take? Why is this? Cannot borrow immutable. Oh. Read will return a, yeah. So we're gonna get, I wonder if we want to use option here or if we want to use result here. So it's definitely possible that we could have errors, and let's go to this first. If we have an error, okay, don't really care what this is, but we're gonna end up like doing something here. So basically we're gonna go and we're gonna figure out like what the thing is and then kind of branch out and like do some decoding. Oops, that's not what I wanted to do. So this test should still succeed. Do we not need this anymore? Cannot borrow. Oh. Do you have to do this way? I don't know that this necessarily is not implemented for VEC. So maybe we still need to do, oh, come on. As me a slice. Is that still required then? Doesn't have its size known at compile time. Is not implemented for Can you call read on a non-immutable? Cannot borrow immutable local variable reader as mutable. Okay, so it does need to be mutable. And this needs to be mutable so it can write into it, which we know. The size for values of give me the vec macro. Where's collections? And I need vec. So I don't know why it can't borrow. Oh. Because it's not immutable. This seems dumb. That it needs to be immutable to be. It doesn't have a known size of compile time. So I thought that like this would automatically dereference it into a slice. But this doesn't implement read, I don't think. Cannot borrow. Yeah. I always forget the syntax for this. Rust array literal syntax. Is the first one to type or is the second one to type? Okay. Yeah. Oh. I think that's correct. The following implementations were found. Wait. But this is what I don't understand is. So this has to be mutable. Expected. The following implementations were found. Is this a mutability issue? Or is this... the binary operation equals equals cannot be applied to option instruction. Okay. I debug clone. Does that make that go away? Oh, and this needs to be macro. Okay. So we're somewhat better. We have the rest of these errors gone. Read's not implemented for U8. The following implementations were found. A slice of U8 as read. See, this is what I don't... Do I need the prelude? Is that... Is this going to import something that I needed to make this actually function? Yeah, see, I don't get that. I wonder what other asserts there are. Equal, I guess. So I don't know why it wouldn't let me do that. Unused import, prelude. Maybe we don't actually need that for anything in here right now. I don't know. But it's not satisfied. Why is that trait not satisfied? And like, is it this? Just borrow the slice. Yeah, so this is what I'm doing. Wait, is that really it? I just need to do that. That seems real ugly. Uninitialized first. That's fine. So this fails. Remove this mute. How? Well, I can't remove that mute. What do you mean it doesn't need to be mutable? It has to be mutable. It's writing into it. What? No way. Okay, so I mean, we can make it a vector and pass that. But I don't think we want to do that. So that initializes it to 0. But I don't understand. Just empty data. Panicked and assertion failed. remove this mute. But that's not even the data anymore. Did it not save? It 100% has to be mutable. Like, why do you think it doesn't have to be mutable? I don't understand, like, why it thinks it doesn't have to be mutable. And this is the other thing I don't get. So, is this not... What is it getting? And this is the thing, I don't know why we can't use assert here. Let's debug this. Cannot apply unary operator. Negate to option instruction. What? Oh, assert equal. That's like what the correct thing would be. This is not right now. All we need to do is get to the part where this code runs, and we can see what's getting returned here. So we're going to... Oh, that's all Git stuff. This is what I want. Oops. Step into... Yeah, that's easier. We're just gonna continue. So it got some. How the fuck did it get some? How did it get some? There's no data. It's an empty bullshit. Can I unwrap do we not know what the sum, like what it I mean it has to be a sum instruction, but okay, fine. Let's kill this. Where's continue? Yeah, fine. Like, so it's the read always succeeds. It just returns 0 bytes. I guess so. I guess that you don't get an EOF. Like if we were to Rust Is there like a buffered reader? This is, I think, what we want. Adds buffering to any reader. It can be excessively inefficient to work directly with a read instance. For example, every call to read on a TCP stream. Blah, blah, blah. I guess how would you know? So, Rust read U8 EOF, because that's what we realistically want. Maybe we need to give it a like an iterator instead. Each call to read may invoke a system call, blah, 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 blah. Rust, reader, test. Let's see what they're doing in here. This probably is what we want to be looking at. This isn't exactly what I want either. So this makes sense. Part of our problem is that our reader here is a straight up array. So we want something that is gonna actually have like an EOF, and I don't know, like that ends basically. Like in Go, you would use buff.io because it tracks the like the cursor in your input, and maybe that's the move. Maybe we wrap these in like a buff.io. Where's the stop button? Oh, here it is. Okay. Rust buffer reader. Actually, you know what? Give me a second. Let me look at something that I have over here. I'm not sure if I'm allowed to show this yet. So I have to wait. But this likely... You know what might be a good resource also is where does he put the code? Is it on GitHub? No. Here. This is the kind of thing that he's going to have probably tests for, and we can see what he's doing. He did like a RISC-V thing. any tests in like any of this? Not helpful. I thought he did like a whole like RISC-V implementation or something where he built like a emulator for it. Maybe it's not up here. No. And I think it was after some of this stuff. That's not what I want either. Is this what we just looked at? Yeah, this is what we just looked at. We'll use buffered reader for right now, I think. Oh, but I have to... Just unit test reader. I also might have stuff from like way back in the code for synfuzz. That'd be in here. Maybe it is just using a vector then. Like this is the part I don't get, is like why that's traits, that's it, uppercase. So unused variables B's, which is fine. So we're still getting, like, this is still succeeding. Did you read exact? Expected one argument. Oh, so it just expects to fill probably. Okay. All right. So that worked. Now it's trying to fill the full buffer. And we've got all of our warnings gone, I think. Cool. So we have done this. Still not sure why we can't Method not found in... Oh, that would be the right way to do it. All right. So if we have empty data, we properly do this. Now, let's get back to here. So the first thing that we're going to do is we're going to look for a 2 operand arithmetic instruction, I think. Or we can do a conditional jump. MSP430 instructions. This is the same doc. Yeah, so it has 3 formats of instructions. What's 5.8? So I don't know if it makes a difference, like which one we start with. If we look at what Josh did here, he's doing, I think, this weird thing where he's using like the Python array index to like figure out like the beginning. So like type 2 instructions all start with 1, but then differentiate by 3 more bits. I think he's looking at like the first byte or something or whatever. I don't know if we want to go that route. So assuming we get the first byte. We're going to first byte, and we are going, let's see if, what is going to be the easiest to parse? I think it's going to be these. And can we always just look at the first 3 bits? It looks like that's the case. We can always look at the first 3 bits. So we are going to take this and we're going to AND it with let's get our terminal up and into like a text editor that actually is, you know, decent. All right. We want the first 3 bits. So our mask is going to be 1 1 1 0 0 0 0. So this would be 8 9A B C D E. So E0 is our mask. We can do this actually. Type match ins type. So if it is if it is I think we're going to want to check to see if let's just say this. So it would end up being one, two, three, four, five, six. So it's going to give us I wonder if we always grab that, like always grab the first 2 bytes. So this is 2. So this tells us the jump instruction. All right. So we're going to match based on the condition. Yeah, so this is the part I don't like. Say we go to microcorruption. Let me switch over to this really quick while I log in. I don't know, we'll just grab any of these, doesn't really matter. So we go here. We see that some of these are, in fact, 4 bytes. Like some of these moves are 4 bytes. This move right here is 6 bytes. So where would a move fall into? A move. So like the calls are also 4 bytes. So we're doing call. So the so these are always just like 1 for these. Yeah, it's so strange. And what is AS? Oh, so that's the addressing mode, I think. If we look here, though, are all the jumps. These are always 2 bytes, it looks like. So maybe we do it as 2, and we try to read 2 bytes, and then we convert the little endian value into okay, maybe U16. What's the type? Is it U16? From LE. What does this need to be? Oh, first from, no, U16 from LE bytes. How does from LE work then? First from LE. Oh, so that's if it's a number. We could from LE bytes. Yeah, and this you can pass in. Okay, that's what we want to do. From LE bytes. First. And can this fail? What does this return? It always returns a U16, which is fine. We don't need anything fancier than that. And all right. So all right. Const jump mask. Can we not do that? Missing type. U16. All right. Wait, why did I do that? It would end up just being 001. Because nothing else is 001. Yeah, okay. All right, if first word and jump mask is jump mask. So then we got to get the condition. Our condition mask (16) 0 0 0 1 1 1 0 1. Right. We might want to clean these up later just because they're being done as 2 bytes worth of binary, which kind of sucks. But jump condition mask match condition. All right. So if our condition is 0, so we have 0, we have 1. We have 2. So this is JNE, JNZ. This is JEQ or JZ. This is JNC, JLO. 2, 3. Oh, fuck off. All right. 3 is JC or JHS. And probably 4. 3, 4. That's JN 5. JGE 6 is JL. 7 is just an unconditional. All right. Unreachable. Yeah, so we should never hit this. This would be really, really bad. Like we literally could never hit this because we only have 3 bits worth of data. We need to figure out how we're going to encode the data. We're probably going to want to also turn these into either constants or an enum at some point. Oh, you know what though? These are not gonna be shifted, so they're gonna be in their position. So they end up being like whatever those are. I guess we could shift it. It would end up being what, like 8. Let's get some code here real quick. Jump J and Z data equal vec 26.4. Oh fuck! What did I just do? No. Next instruction. See, I don't know why I can't do like, I don't know why that doesn't work. Let's block this out for right. Actually, we can do it this way. Cannot find value B. Is that not the way to do it? Just binary literal. Oh, 0B. I have to prefix it. Okay, it's fine. This isn't found in the scope. First bytes. Yeah. Cannot be applied to option instruction. So it must be because option doesn't implement partial, what is it for compare? Trust, partial EQ, whatever. Yeah. If we do that, like if this implements just like partial EQ, is that usable? Okay, yeah, that works. And it also means that we can switch this back to here. So I think we can just run all the tests now. Run. And I'm missing a token or something. Why is that? Oh. So we had unreachable code, which means we are landing in here. We're shifting here. All of these should be good. Unimplemented This is stupid. All right. We're doing JNZ, I think. Yeah. So we should be able to return like a just like a some instruction, and this should. Oh no. We can just literally like no op this. I hit unreachable code. Is it? Did I shift the wrong direction? Yeah. Okay. What is it? So it's 2064. That would be 0010 01 000 011 0 0 1 0 0. And so if we wanted to do like a different instruction, let's say we wanted to do like a JEQ. I mean, we'll write all of them right now, I guess. Write tests for all of them. This is JNZ. This would end up being this. Condition would be 0, 0, 1. We can do this would be JEQ or JC. So this would be 2 4 2400 would and so if we run this, we should get unimplemented, which we don't. Why? I wonder if I am I am shifting the wrong way. It should be this direction, the other direction. And so it would end up being 10. Not implemented. What does it think it's getting? Does this take anything? Can I take me to the definition? Rust unimplemented. Can I give it a message or not? I can, okay. JZ JLO JC JN JGE JL jump. We'll leave that as unreachable, it's fine. So that succeeds. This one fails. So it's getting a jump. So it's getting 7 when it shifts to the right. Condition mask. So to get 7, it would have to be 4, 5, 6, 7. So these 3. Wait. But I'm putting them backwards. That's why. 6420 is the 6420. So it is the 64 that I should be doing. So this ends up being 0, 1, 1, 0. Zero, 1, 0, 0. 1, 0, 0, 0, 0, 0. Okay. And if we want it to be a JZ, it would end up being, so like this, these are 10 bits, so it's 1 2 3 1 2 3 and 1 2 and then this is 4 8 9 10. So it ends up, so these can all be 0. 0 0 2 0. This should still pass. And then if we wanted to make this condition a jump 0, it would need to be so 2 3 1 2 3. It would be this. So it would be 2 4 0 0. Yeah. Why is it still succeeding? We should be hitting this. condition is... Debug this. Wait, what? Are we not hitting the breakpoint? That's interesting. Are we... But we are hitting this. So we're not getting into here, and that's the problem. Unimplemented J and Z. So you know what, we can just hit a breakpoint right here. First bytes. What? We're getting 32-0. Do I not need to initialize it? Is that... interesting. I mean, we can see if we got... right. Do we not get N? That's interesting. know why it can't give me that. Is n just 0? No way. Terminal. I don't want terminal. I want the output. Where's my output? Run. Oh, it's going to hide the output from us. Rust literal. Did I do this backwards? I wonder if it makes sense to use a vec instead and like. This would be vec sorry. Right? And this would just be that, right? Unsigned car 2. Why does that not work? Oh, I can't do this. It'd be a vac with capac. Yeah. Okay. I wonder if I can do as bytes. I should still be able to do this. There's no reason I can't use the array. I'm pretty sure I have like existing code for this in here. Yeah, I was using vectors. This is all byte order, which I don't want to use. We don't need it anymore for what we're doing. But Yeah, so it could be that. So we can swap this back to a vec. I don't think I want to use a vec. It ends up being this. So I thought a reference of that ends up expected array. From LE bytes. Yeah, all of this is... Yeah, so the problem with using a vec is we still have to turn it into an array, which I don't really want to do. It takes an array and not a slice, I think. Yeah. So I can do this. I don't really want to do that, I don't think. But, yeah, stop and run. Is not implemented for... Alright, so here's what we can do. I might be able to do collect here. That might be enough without having to give it a rocket fish. Oh, yeah. All right. Use standard id. Where's iterator? It's iter. Okay. Like this, I think will end up giving us something that is close enough to what we need. The following traits were not satisfied, which required it to be a mutable vector. Method not found. I might have to do into iter there to actually get over elements. The worst part about this is I'm going to throw all this code out because I don't want it to be implemented this way. A vector, standard, collections, vec. Maybe I want where's iter? Iterator. So why can I not do that? It That's what it is. Iter mute. Okay. What? From iterator is not implemented for you. These are all copy types. Can I call collect on it or not? Trait bounds are not satisfied. Do not need. I don't see why it can't do vec or u8. Oh, I'd have to do take 2, but I don't think even that will work. Because it's going to collect too many items. I kind of think this won't work. Stop it. I think this isn't going to end up working. It's copy though. I don't know why. Just fucking copy it. Either way, let's go back to doing non this. Like there's no reason we shouldn't be able to use u8.2. Like there's no reason we shouldn't be able to use this. Not a value. So this will complain that it's not initialized, and that's fine. Don't need the iterator. Let's debug this. It never hits this because it goes into here. We can verify this by doing this. Yes. All right. So we're succeeding there. Now, we can do this. We're going to do our JNZ. All right. So we're going to read R first. So step over. What? So why is this? We haven't even read. Oh, we did read this. So we did our exact read, and for some reason it reads 32.0, which. Oh, yeah, 32.0. That is correct. These are the right values. So first word ends up being 32. Fuck, we spent this whole time looking at the wrong data. All right. So that's fine. And we're gonna mask off a jump mask. Oh. It's because I'm putting it in backwards. That's why. It needs to be in hold up. All right. There we go. Our condition is which one did I just do? I'm running JNZ. I don't know what this is. Give me like that to S16. It's That's interesting. Oh, because it's 0 prefixed. That makes sense. And then so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which I'm doing JNZ, which would be 20, 0, 0. Let me just fuck this up again. Let's put it in tmux. 20, 0, 0. So this ends up being that's no, so yeah, this would be 0, 0, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0. And so this ends up like here. So we're doing, it's a jump instruction. $81.92. Yeah, so that's correct. So JNZ. Where are we? So we're somehow in here, even though we moved it over. Like, I don't even know how we'd get to 7. This is bad. All right. If we run this, we don't need our n anymore. We can get rid of that. Let's get rid of this. Run. JNZ panicked. Not implemented. JMP. So this is what I don't understand is why. So say we have like this is our this is our value. I guess we can let mask equal condition idiot first word. I'm an idiot. There we go. That's the problem. If we run this now, everything will just work, I think. Panicked. JNZ. All right. Now we're doing it. All right. So now we need to start building like a real condition, and then we can get address or offset, and we'll just do const jump offset. U16. 1, 2, 3. This should be 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So this should be our offset. It's attended offset. First word and jump offset. We don't need that. Okay. Now we know how far we're going to jump. And this is going to be so I don't think Rust supports like ones complement. Rust ones. Yeah. So the numbers on MSP430 are a little weird in that they're ones complement rather than 2. So what we're going to have to do is we're going to have to see do this ourselves like when we actually start printing these things out. But that's not a big deal. So we got to figure out how we want to surface this. All right. Struct. So it's going to have a condition, which is a jump condition. And it's going to have an offset, which they use size. Because we don't get to let it manage. Well, you know what? No, we'll just do a size. What's a sign size? Is it S size? You probably don't have a sign. Sign size. It would end up just being a U16 or something like that. It's fine. We'll do a U16. I16. Drive, debug, clone. That's fine for right now. All right. Let's we'll create a constructor, I guess. Simple jump instruction and new. Addition and offset. We care about the 10th bit. So offset is going to be U16. And the condition will be a jump condition, jump JZ, JZ, JLO, JC. I think this is the correct way to do it. Oh Siri, I don't want you. JC, JN, JGE, JL, JMP. Derive, debug, and clone. Probably want some others in the future. Partial equivalent, probably do want. It's probably copy. I think that's fine. Condition offset is fixed. Offset. All right. So we have to basically do a little bit of magic here to figure out what our offset is. So the way that this works is that the value is using ones complement numbers. So the way that ones complement works is it sets the high bit to be 1 and then inverts it all. So basically what we're going to do is we're going to check that the 10th bit is high. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to take our offset, and it is greater than 0. We need to negate it. Sorry, 1 second. I'm going to move headphones around. Let's see, 1 second. Can I do this? Is this valid? Yeah, that is right. Okay, cool. All right. So we are going to so this is weird. It's a 10-bit number. So it's gonna be so this is only 10 bits. So we're gonna have to mask off the other ones. Second to turn the lights on in here. So let's do this a hand first. Let's say we're working with like -6. So -6 would be 0, 0. I forgot something here too. 0, 0, 0, 0, 0, 1, 1, 0. So this is 6. To make this negative, it would be this, 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 this. So we're going to grab so rust bitwise not. Is it not? So we're going to take our fixed offset equals offset. So we're going to negate it. So every bit is going to flip. -1 times that. So if we have this, we're gonna negate it. Uh, 1, 1, 0. And because of this, we're gonna have 1, 1, 1, 1, 1, 1. So we're gonna do this. And then we need to mask off 1, 2, 3, 4. 1, 2. I think this is correct. So we're turning it into a positive number. And then we're going to multiply it by 1. And and we're fine here because normally we'd be afraid here that we were going to have an issue because there's not enough bits, but we know for a fact that we have enough bits in here to represent the entirety of it. So jump new jump condition J and Z jump instruction new jump condition JZ offset let's add some comments also. One's complement so we need some bit magic to have a negative offset, convert it into the actual number, representing that's one of the annoying things about this is it can't do like the auto formatting. So we this should be correct now. Are we testing? We're testing JZ and we're testing JNZ. Let's change this real quick. Sum. I think this is still sufficient to run these tests. Equals can be applied to that, so we need a partial equality. Should be able to copy as well. Yeah. interesting. So this is giving us back a none. Oh, it's not equal to none. Cert equal ins then condition self jump condition self condition function return, because we don't want that. Condition offset self I16 ins jump condition and there should also be a method not found in can you unwrap a sure. I offset is 0. A local variable with similar name exists. Is it supposed to be all uppercase? Yeah, it is, okay. Chop mask. Masks off the we're gonna slightly change this code, I think. maybe not. It's kind of lazy. The high 3 bits. Check. One. It's present. This describes a JXX instruction. Masks off, used to denote the jump condition, jump offset, masks off, lower 10 bits, used represent the offset. This can be a negative offset and is represented as in one's complement. All right. So condition describes the jump condition. Condition we'll go with that syntax. This is JLO. JC. So something we might be able to do is we might be able to turn this into like a C style enum where these have the actual values and then like automatically like handle like this, because we are figuring out the number. We can just do a jump condition like from and then the number rather than having to match on this. And basically we just have to make sure that the condition is between 0 and 7, and if it's not, then we create an issue. I think we'll take care of that later. Rust enum from int. Yeah, so it ends up being like this. So I don't think you need the. I think there's like a different way to do it, like this, the C-like ones. Like I think you can do it this way, where like where are we? Like I think it ends up being. I think it's like a repr C, and that ends up letting you do it. I just don't know if we can do a from or not. To do. Convert from the condition value. Yeah. So, something to think about for the future, but so we're gonna have to figure out all the other jumps here. We probably also want to sort out negative values. I'm gonna stand up for a second, take a drink of water. But it's been a little bit of a slow start, but I think we're finally making some progress here. The code is still very messy and not great, but cleanup can happen soon. I think once we get the stuff working, I still need to figure out how we're gonna end up getting us into here. We might make instruction in enum, and it becomes either like a jump instruction, or a like whatever else we have, jump or two operand arithmetic or single operand arithmetic. If we're doing a emulated instruction, it's not going to have its own special type. The special type here, or like the emulated instructions, will just happen. Like we're going to implement display probably, for or format or something for each of the instructions, or for instruction in general. And the way that it'll end up working is that we'll build in the support to automatically figure out like if we're an emulated instruction or not. Like this has all the like the actual situations, so we can see like if we're doing one of these things, and if we are, we just print the proper emulated instruction. So we might want to end up doing some more generalized ones complement implementation than what we have in here. Because this is 10-bit logic, it might make sense to do it elsewhere, because this is still probably going to be like special. Let me see if I can find like a real negative jump in here. Let's see. And we can grab it from that, and that way we know it at least is good. So 4416. Yeah, so this is a negative jump right here. 23F9. So like we can like figure out what this is. F923. So that ends up being 1111. 9 would be 1001 0010 0011. So we can see that from here, this is a jump instruction. The next three here are 000, which means it's JNZ, as we just saw. JNZ is our first one, and then our bits are, oh shit. So I didn't think about this, but man, that is no, because we're little endian. Right. Okay. Yes. All right. So this is gonna be fine. So F923. So new negative jump. F9. And so this ends up being, what's our 10-bit number here? It's 1 1 1 1 2 3 4 1 0 0 1. So we get 0 0 0 0 0 0 0 1 1 0. So this is negative negative 6, which this is 1 2 3 4 5 6. That's weird. 1 6. I wonder if instructions back, and that's why. So this is also interesting, though. Looking at this, because instructions can get to 3 bytes, I wonder if we need to like what the correct way to parse this is, like how you get 3 bytes in. I don't know. We'll figure it out when we get there, I guess. Right, so you have to do the decoding first, but so let's go to the actual byte stream here. We're at what, 441C. Oh, because it would start at 0, 0 here. That's why the whole thing is backwards. So we got 441C, one. So F E D C. 441 F E D C. So 9F 4F 5846 0024. Yeah, so if you're starting here, how would you know how many bytes to go in unless like what's a move instruction encoded as? So a move is so your opcode ends up being these 4 bytes. So this would be 4. Oh, because it's they're all, yeah. So your first 16-bit value is that. So like 4F. So this is the first one, not here. That makes sense. So you're always gonna be able to do it properly. I keep getting the endian is screwed up because I'm thinking in 32-bit numbers rather than 16. So you're always gonna get 16 bits at a time. It's just that your 2 bytes are gonna get flopped, not the whole instruction backwards. So we said this was -6. We should be able to run this test and get -6. And it works. So this was, what, 4416. And that's weird, though, is like, oh, those words. So it's 1, 2, 3, 4, 5, 6. That makes sense. It's 6 words, not 6 bytes. Backwards. We just need to make sure that we're clear about that. Offset. Jump. Condition to all right. So let's run some more tests, and we can get this finished up. So that's pretty good. I mean, we have. I mean, these are the easiest ones I think to implement is the jump instructions, but I don't need this, do I? Can I run all the tests? Run test. Yeah. So these probably are the easiest instructions to implement. And it's not the best code, but I think it's a good first pass. How long have we been going for? We're about 3 hours in. Let's get these tests written for the rest of our jump cases. So we need JLO. that ends up being one. So these are our conditions right here. So JLO is going to be 3. So that would be 1 here, here. So 0, 0, 2. What is that? It's 8, 9A. Did I not get all this stuff? All right. Did I fuck something up? Yeah. JZ was in, yeah, so JZ, JLO. Interesting. This did pass though, yeah. Did I do my math wrong? Which test failed? All right, not which test, but which part of the test failed, which assertion? 149. So this, really? Why does it think that that's so strange? Debug. That's so weird. It shouldn't be. That's 8. Oh. 8, 9, A, B, C. It should be C, not A. Just some bad math. Right? 2. 9A, B, C. So JC 0, 1, oh, it should be 2. So it is just 8, okay. It would be good. 2C is correct. Is my test bad, the JLO? So 0, 1, 2. And JC is 3. Yeah, so this is right. And so then for JC, this is the one, so JC would be, this is 2C. I changed it up. So this is 8, 9A, BC. So this is, yeah. Wait, so did I? This is correct, right? Like I didn't make a different mistake that I'm not seeing. And then the next one is I just did JCJN. And this would be this. And so this becomes 3, 0. JN, JGE, so this ends up being that. So that's 3, 4. So that's JL. So this becomes so it's 3, 8. And then JMP. JMP becomes that. So that would be 3C. All right, so we have all of the jump instructions implemented at this point. We've got tests for them. We've got tests for positive and negative values. So we've got a handful of things left we need to do. we basically are going to have to implement decoders for all of these and for these. I'm not sure if these are easier to implement than these. These, I think, are probably less bytes, so it's probably less parsing, but once we get into these two areas, though, we have to start getting into what are those things called? It's there's this like special addressing mode that I think it's this part. Yeah, it's these there are these like constants where each of these constants has like a special meaning. I remember doing this last night. All right, now the question is, do I get Git functionality for free, or do I need Git installed? Let's see. Can I do a commit now, and will it show me stuff? I don't want idea in here. Shit. How do I... Oh, this sucks. I just want like a command line that I can do this stuff on. I can do it from here. Mount C. Of course you can't access all that shit. Users, J. Rosner. Oh, where am I actually in here? That is a good question. Oh, this is gonna suck. Everything's gonna be executable. That sucks. What's the easiest way to do this? Author. New nominal command phrase coming. So I don't even know how to set this up. One added edit to was found. No, just commit it. So we did that. Can I push? Let's all learn how to use CLion's Git functionality. New repository, MSP430 dis. That's all fine. Can I? Oh, great. Can I set a remote? I can do it here. Wait. Why? Yeah. Do I need that? All right, git remote, add origin. Got a feeling this is not going to work. Refresh. Did that push? No, it didn't push. How do I... How do I set up... Manage remotes. Yeah, so that's good. The remote's set up. Push. Yeah? Yep. Okay, so this is the problem, is I don't have a public key set up in here. Fuck. Shit. I do have it in here, so that's fine. Hide the screen? Is there something here that's not... Nothing in here is sensitive. Is there something here that's a key or something? Do I need to burn something? Oh yeah, I'm gonna, as soon as I actually do this, I'm gonna hide some of it if I need to. I think I want to get not commit any of the. Yeah, so I don't want any of the. How do I keep? Unstage and remove paths from the index. Ignore. Get remove view files. That's what I want. Yeah. Okay. Yep. All right. Cool. So I think I can just do a get push in here. God damn it. Oh, I can't even do that in here either. I am gonna switch this for a second, so I can get into GitHub and not accidentally leak anything. Let's see. All right, I think we're all good. All right. Cool. Let's add a few other things that we don't have in here right now. Disassembler and Rust. MIT license. Yep. this should populate all the stuff. All right. I think I'm gonna wrap up for the day. We're about 3 hours in, and I don't really feel like jumping into the next set of instruction type. We got a handful of people here. Let's see if there's anyone worth rating. Thanks for all the help, Mr. Edmakes. You were super helpful when I was making mistakes, and hope everyone else enjoyed the stream today and learned something about MSP430. I think we're going to probably keep working on this probably for a handful more days until this is done. And then the goal is going to be to integrate this into Binary Ninja as a native plugin for it. And then building probably a loader for iHex so that we can load like iHex files that have firmware in it. I'm probably not going to bother writing a loader for the microcorruption like wargame stuff, just because there's not really like a fixed like file format for it. But I feel like iHex is one of the few that are gonna be like really helpful to have, and I'm gonna need it for other embedded stuff. So it seems like a pretty like easy and straightforward like thing to start implementing for that. While we do this, let's see if there's anyone that we could raid. See if anyone's working on anything cool. Hacking esports. Doing some Rust? Oh, this is the game Rust. Let's do some hacking. This seems like the move. All right, everyone, have a good night. I will see you all next time. Probably tomorrow will be the most likely point. Bye, everyone.